In part 2 of our lesson on solving right triangles, we're going to learn the method you'll need to use for solving those right triangles. So you can see there's 3 steps in the method, and I think the best way to learn this method is to just dive right in and work an example problem. So here we're being asked to solve right triangle ABC, and we're given that angle C is 90 degrees, angle B is 51 degrees 15 minutes, and side A is equal to 10.3 centimeters. Remember, anytime you see a lowercase letter, you know that's going to be a side. Now, as we look at our method, step 1 says to make a drawing and label all the known information on your drawing. So let's start with angle C has to be the 90-degree angle. And the A and the B could go anywhere, so I'll put the A here, the B here. The B we know is 51 degrees 15 minutes. And then side A has to be 10.3. And now remember the naming convention. Side A will be the side that is opposite from angle A. So that means this is side A. So that's going to be 10.3. Now, step 2 says we have to find all the missing angle measures and side lengths. So we see angle A is missing. That's probably the easiest thing for us to start off solving for. We learned in a previous lesson that the acute angles in a right triangle are complementary. So we know that angle A plus 51 degrees 15 minutes has to be 90 degrees. So then that means we can do the subtraction. We have 90 degrees. We want to subtract away 51 degrees 15 minutes. Now we know we're going to have to borrow, so the 90 is going to become 89 degrees and 60 minutes. We know 60 minus 15 is 45. 9 minus 1 is 8 degrees. 8 minus 5 is 3. So we know that angle A is going to equal 38 degrees 45 minutes, and we have to label that answer on our drawing. All right, so we're done with our angles. Now we need to find the 2 missing sides, and we know that this side is opposite of angle B, so that means it's going to be called little b, and this side is opposite angle C, so it's going to be called little c. Now we can use SOHCAHTOA to find the missing pieces. Remember, when you have a right triangle, you get to use SOHCAHTOA. Now, whenever you're solving for the missing parts in a triangle, you want to use as many of the givens as possible. So we were given 51 degrees 15 minutes, and we were given 10.3 centimeters. Now, relative to that 51 degrees 15 minutes, B is the opposite leg, and 10.3 is the adjacent leg. So we know if we're using opposite and adjacent, that means we're doing the tangent function. So tangent of 51 degrees 15 minutes is going to equal the opposite leg, which is B, divided by the adjacent leg, which is 10.3. Now be very careful in your work to show that you solve for the missing side. So I'm not ready to pick up my calculator yet. I have to do the algebra first. We see that the only thing we need to do is cross multiply the 10.3 up to the left-hand side. So the left-hand side is going to become 10.3 tangent of 51 degrees 15 minutes, and that's going to equal little b. And now you grab your calculator, punch in 10.3 times the tangent of 51 degrees 15 minutes, and we have to decide where we're going to round to. We can see the sides here were rounded to the tenths place, and we see that b is going to be approximately equal to 12.8 centimeters. I circle my answer in my work, and then I come over to the drawing and I put my answer there, 12.8. Now to find side C, you have a couple of options. You might be tempted to use the Pythagorean theorem because you have this leg which is 10.3 and this leg which is 12.8, but your accuracy won't be as good because remember 12.8 was not a given value but something you solved for and rounded. So the safest way to solve for C is going to be to use the givens, which is the 51 degrees 15 minutes and the 10.3. Now, relative to the 51 degrees 15 minutes, we have to figure out which part of SOHCAHTOA we have. We know the 10.3 is the adjacent leg and C is the hypotenuse. So if we have the adjacent leg and the hypotenuse, we know we're using cosine. So now we can come through here and say that the cosine of 51 degrees 15 minutes has to equal the adjacent leg 10.3 divided by the hypotenuse, which is C. Now we have to solve for C, and C is in the denominator, so we're going to need to cross multiply up the C, and we'll want to cross multiply down the cosine of 51 degrees 15 minutes. So we get C is equal to 10.3 divided by cosine of 51 degrees 15 minutes. And now we go ahead and pick up our calculators and do this calculation. 10.3 divided by cosine 51 degrees 15 minutes. And we see that little side C is going to be approximately 16.5 centimeters. So we come up to our drawing and we label the 16.5 on our drawing. In this next example, we have to solve right triangle PQR, where Q is the 90-degree angle. So let's go ahead and label Q is the right angle, and the P and the R could go either place, so maybe we'll put letter P here and we'll put letter R here. Now we're ready to label the rest of the information and then solve for all the missing sides and angles. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. We know that side P is 17.04, and that has to go opposite of angle P. Side R is 25.42. That's going to go opposite of angle R. Now, probably the easiest thing to solve for first here would be the hypotenuse of the triangle. Since we have a right triangle, we're allowed to use the Pythagorean theorem. So we know that 17.04 squared plus 25.42 squared is going to have to equal lowercase q squared. So we'll have to take the square root of both sides. And of course we know since q is the side of a triangle, it has to be positive. Now we grab our calculators. We have to hit the second key to get at the square root button. Enter 17.04 squared plus 25.42 squared. Close your parenthesis, then hit the enter button. And we can see that the sides that are given have 4 significant digits, so we're going to be rounding our answer to the hundredths place. And rounding this to the hundredths place, we find out that Q is going to be 30.60 inches. And we put that on our picture. Now we're ready to find our angles. So it doesn't matter which angle we try to find first, but remember to always use as much given information as you can. Since the 17.04 and the 25.42 were given to us in the problem, I want to use those to find angle P. And anytime we have a right triangle, we know we can use SOHCAHTOA. Let's find angle P first. And opposite leg and adjacent leg means we're using tangent. So we know that the tangent of angle P is going to equal 17.04 divided by 25.42. Now remember, you have to show all of the algebra in your work, and we're going to need to take the tangent inverse of both sides. So we'll take the tangent inverse of the tangent of P on the left-hand side, and that means we have to take the tangent inverse of 17.04 divided by 25.42 on the right-hand side. Tangent inverse of the tangent of P becomes P. On the right-hand side, we're going to grab our calculators, hit second, get tangent inverse, 17.04 divided by 25.42, close your parentheses and hit enter, and we see that that comes out on our calculator. We get 33.83546, etc. Now, this is going to be in degrees, but if we look in the problem, we're asked to round our angle answers to the nearest minute. So we're going to have to convert angle P into degrees and minutes. Now we know that it's going to be 33 whole degrees, and then we're going to have to convert the decimal degrees into minutes, and we know, we learned how to do that earlier. We know we're going to take that and multiply by 60. I think the easiest way to do that on your calculator is to just subtract out the 33 so that you're now just left with the decimal part. Then take that decimal part and simply multiply times 60, and you'll see that if we round that to the nearest minute, we're going to have 50 minutes. So we have 33 degrees, 50 minutes. Now, if you feel really confident in your answer, then you could go ahead and use the fact that P and R have to be complementary, and to find angle R, we could just do 90 degrees minus 33 degrees, 50 minutes. We know we're going to have to borrow. That's going to become 89 degrees in 60 minutes. 60 minus 50 is 10 minutes. 9 minus 3 is 6. 8 minus 3 is 5. So we see that angle R is going to equal 56 degrees, 10 minutes. If you want to be extra sure, and as I suggested earlier, only use the givens, we could also solve for angle R using the tangent function, because we have the opposite leg and the adjacent leg. But as I said, if you feel very confident in this answer for angle P, which we do, we know we did that correctly, then we can go ahead and subtract from 90 to find angle R. If you did elect to use the tangent function, you would have said tangent of R is going to equal 25.42 divided by 17.04. We know that we have to take the tangent inverse of both sides. So we would take the tangent inverse of the left-hand side, which is tangent R, and we would have to take the tangent inverse of the right-hand side, which is 25.42 divided by 17.04. We know the tangent inverse of the tangent of R becomes R. To do the right-hand side, we're going to need to do the calculation. So we hit second, get the tangent inverse, 25.42 divided by 17.04, close the parenthesis, hit enter, and we get 56.164538, etc. Now, we know we have to round to degrees and minutes. We know that's going to be 56 degrees, and we know, as before, we're going to have to multiply the decimal part by 60. So once again, your best bet is just subtract away the 56, hit enter, and then multiply times 60, and you see that that 9.87, etc., is going to round to be 10 minutes. So we get the same answer that we had before.